Exercise resistive circuit. Consider the electric circuit shown in the document below. Given Vp and 12 volts, R1 equals 5 ohms, R2 equals 1 ohms, R3 3 ohms, and R4 4 ohms. The resistance of the battery and the wires are neglected. Part 1. Determine the equivalent resistance of the circuit. In order to determine the equivalent resistance of this combination, we will start with R1 and R2. These two resistors R1 and R2 are connected in series. Why? R1 and R2 share one common point, which is D, and nothing else is connected to this point. Yani only R1 and R2 are connected to this common point. The terminals of R1 are A and D, the terminals of R2 are D and B. The common terminal is D. In case of series connection, we add up the individual resistances. Therefore, R12, the equivalent resistance to R1 and R2 in case of series connection is R1 plus R2, which is 6 ohms. Since R1 equals to 5, R2 equals 1, the equivalent resistance is 6 ohms. Now, we can replace these two resistors, R1 and R2, by a single resistor R12 of resistance 6 ohms. Yani instead of placing R1 and R2, we connect a resistor R12. R12 and R3 in this case are connected in parallel, since they share two common points. R1 and R2 are connected to A, R12 and R3 are connected to B. They share two common points, A and B. Therefore, R12 and R3 are connected in parallel. In case of parallel connection, the equivalent resistance of R12 and R3 is R123. In case of parallel connection, 1 over 1 R123 equals 1 over R12 plus 1 over R3. If we take a common denominator and we flip the fraction, we get R123 equals to R12 times R3 divided by R12 plus R3. We get R3 3 ohms. 6 times 3 over 6 plus 3 equals 2 ohms. كمان we can replace R12 and R3 by a single resistor R123 of value 2 ohms. هلا the final step بسميها R equivalent. R123 and R4 are connected in series, يعني we add up R123 and R4. Therefore R equivalent equals to R123 plus R4 equals 6 ohms. R123 equals 2 ohms, R4 4 ohm. The equivalent resistance of the circuit is 6 ohm. Therefore, we can replace R1, R2, R3, and R4 by a single resistor, R equivalent 6 ohms, and this battery is still delivering the same current. Deduce the main current I. Now, in order to calculate a given current in a given branch or voltage of a branch, we must apply Ohm's law. Ohm's law, voltage equals resistance times current. But we need to choose the convenient voltage and the convenient resistance. By applying Ohm's law, current equal voltage over resistance, I equal V over R. In order to find the main current in the circuit, we take the voltage of the battery and we divide it by the total resistance. In this case, the voltage across this resistor, which is R equivalent, is equal to the voltage of the battery, and current I passes from A to C through R equivalent. Vp and 12, R equivalent 6, we get 2 ampere. Calculate the voltage of the branch VAB and VBC. VBC. In order to determine the voltage of a given branch, we need the resistance of this branch multiplied by the current. In this case, VAB, in order to find VAB, we take the total resistance between A and B, which is R1, 2, 3, وكمان equivalent diagram هون بتساعدنا. If we use this diagram, VAB is a voltage across R1, 2, 3, and VBC is a voltage across R4. These two resistors are connected in series with the battery, therefore the same current passes by them. VAB equals to the resistance R123 multiplied by the main current I, and VBC, we take the resistance R4 multiplied by the current I, we get 4 times 2 equals to 8 ohms. I did use I prime and I double prime, also we apply Ohm's law. I equals to V divided by R. I prime equals to VAB I prime, by applying Ohm's law, I equals to V divided by R. To determine the current through a given branch, we take the voltage of the branch divided by the resistance of the branch. If we need to find I prime is a current in the branch AB. So I prime equals to VAB, voltage of the branch, divided by the resistance of the branch, which is R12. And I double prime, we take the voltage VAB and we divide it by R3, وكمان هيدي equivalent diagram بتساعدني. I prime is a current in R12, I double prime in the current in R3. So I double prime equals to the voltage VAB divided by R3. I prime is a voltage VAB divided by R12. Calculate the electric power delivered by the battery dissipated between A and B. We know that the electric power is equal to voltage times current. The power delivered by the battery, we take the voltage of the battery multiplied by the main current, 12 times 2, 24 watts. The power between A and B, we take VAB times I, we get 4 times 2, 8 watts. 6. Calculate the energy dissipated by the circuit during 2 minutes of functions. This circuit is a resistive circuit. The total power, or the power delivered by the battery, is totally dissipated by the resistors due to Joule's effect. Energy equals to power times time. In order to find power in joules, energy in joules, power in watt, and time in seconds. 2 minutes of functioning, 2 minutes, we multiply by 60 in order to convert from minute to second. Therefore, the energy will be 2880 joules. Part number 7. The terminals A and B are joined by a wire of negligible resistance. Calculate the value of the new current sent by the battery. A and B are joined by a wire. So R1, R2, and R3 are short-circuited. No current will pass by these two branches. The entire current, or the whole current I, will move in this wire. So we draw the equivalent diagram. A and B is short-circuited. Therefore, the total resistance is R4. By applying Ohm's law, I equals to VPN over R4, 12 over 4 equals 3 ampere.